Hi friends, when we are building any software system, it's really a big task, size of an ocean, and it's quite a difficult task to conceptualize the whole thing at one go. So we need to compartmentalize the things and make sure that we follow some process so that the whole work can be done smoothly, efficiently. When we are developing any software system, we need some proper way of documenting the things, and one of the best tools for documenting the design process of any software system is UML diagrams. So let's try to understand what UML diagrams are and how they can help us in our project design. So let's get into that. The objectives of this session is to understand the need for UML in the project design. So when we are developing any software project, the first question comes is, why do we need to do all these circles? Why not directly start writing the code and all that? That's a common experience when everybody is in a hurry to start directly writing the code. But what goes wrong is the proper ideas, the proper planning. If we don't have a proper plan, it's definitely going to fail. So we need some guidelines to create that proper plan, and one of the guidelines is the UML diagrams while developing a software product. So we need to understand what is the need for UML diagram in the project design, and the other objective is to learn the key UML diagrams we are going to use in the product design, like use case diagram, class diagram, sequence diagram, activity diagram, state diagram, component diagram, and deployment diagram are the commonly used UML diagrams we have. Then we want to know how to apply UML diagrams to our own project ideas, and we want to see the various free tools available to draw these UML diagrams. So first thing is, what is UML diagram? So it's a visual representation of a system. So when we are building a system, we have many ideas, and these ideas, as long as they are in our human language form, there is going to be a lot of confusions. To make sure that there are no confusions, we have to put that on a visual way. So that's a visual representation of a system is what a UML diagram is all about. It stands for the Unified Modeling Language. The UML is the short for the Unified Modeling Language. This is used to convert a text into a graphical representation. All our ideas, all our thoughts, we put it, freeze it on the paper in the form of visual representations. That's what UML diagram is all about. So it's a standard way to visualize the design of a system. So once we have a standard, then everyone will visualize the thing put on the paper the exact same way. So whatever we want to convey to other party, so whatever ideas we have in our mind, if we put it properly on the paper in the form of visual form, then the exact same idea will be transferred to the other end. So it will be quite easy, and the best way to transfer ideas from one brain to another brain is through the visual form, and that is where UML come to our aid. Yes, of course, one picture is worth 1,000 words, so you can talk about your ideas. If you want to convey your ideas from one person to another person and use our language, then there will be confusions, because mostly our human languages are context based. It all depends on the current situation, current mood, and all that. So what we are talking and what the other person is listening, there may not be a proper correlation. The all depends on the mood and all that, and that's going to be a quite difficult task in telling the exact information from one end to other end. So better, instead of talking thousands of words again, all that, just put in one picture, and that conveys most of the information we wanted to convey with no confusion. Unambiguously, we can convey it. And this is developed by OMG, that's the Object Management Group. So UML diagrams, in a simplest way, if you want to understand, then you can think it as a blueprints that describe either the structure, that is what parts of the system has and how they are related. So what are the parts a system is consisting of and how they are related. So this is a structure of a system. So the components of the system are shown here, and how they are related to one another. That's one aspect of the representation, and another is about the behavior, how this system works, interacts or changes over time. So that's a dynamic component of the system is represented in a behavior way. So why do we require UML diagrams? So UML diagram provide clarity in design, help to communicate ideas across the teams. Yes, because there is not one team working for start to end. There will be many teams working. So each team specialized in different activities, like collecting the requirement. One type of actions are required. One type of thing is required. So people who have uh, a better way of collecting the information are well suited for requirement collection. Same way, there are some people who are good at understanding, visualizing the things, so they can be good at putting on the design side. Some people are good at coding, so they can be in the implementation. Some people are good at identifying mistakes, so they can be well suited for testing and all that. So there are different teams across the one product design. So it is essential that across these teams we need a foolproof way of communication, and there UML comes to our help. And it's very much useful while detecting the design flaws early before coding. So before coding, you can just visualize all the diagrams and then try to understand, is what the client wants, is it exactly put it on the paper or not. If anything is not right, then you can make all the corrections, design, check all the flaws, and make all the necessary corrections before actually getting onto the coding. So lot of time can be saved, lot of energy can be saved if we do it on the initial place, finding the flaws and correcting them before actually coding it. And most important thing is it serves as a document for future maintenance, as well as document for transfer of information from one team to other team across the design. So it's a better documentation. So mainly the UML diagrams, we can say that there are two groups of UML diagrams. So one is the structural diagram that talks about what all components it's having, like the class diagram, component diagram, deployment diagram, and so on. On the other side, it talks about the behavior of the system, like the use case diagram, the sequence diagram, activity diagram, state machine diagram, and so on. So there are totally 14 diagrams, 7 structural diagrams, 7 behavioral diagrams. But most commonly for elementary users like us who are designing their final year projects. So for them, just 7 diagrams are sufficient, like use case diagram, the class diagram, sequence diagram, activity diagram, state diagram, component diagram, and deployment diagram. So these 7 diagrams are enough as of now to take up our task. So let's just look in detail what these UML diagram types are. So structural diagrams, that gives a static view of the system, like a class diagram. It shows the classes, attributes, methods, and their relationships. Object diagram is a snapshot of objects and links at a point at any point in a time. The component diagram shows how system components are organized and they are interconnected. Deployment diagram talks about the physical deployment of the hardware and the software and how things are interrelated and all that. And the package diagram organizes the elements into the packages. When we are talking about a bigger system, then it is better to uh, pack different things into packages so that the abstract level it is easier to understand. So that's a structural diagram. So looking at the behavioral diagrams, that gives a dynamic view of that. Use case diagram is the one where users interaction with the system is noted here. Then we have system say, sequence diagram. That's how objects interact in time order. So what happens first, what happens next, and all that in the along the timeline, what is happening at different times. That sequence diagram talks about. The activity diagram talks about the workflows and the processes, so the how that so it's something like the flow chart and algorithm like. So state machine diagram, it's talking about the states and the transitions of an object. So if it is the object is behaving differently at different times, that means for each behavior we have a state, and from state to state how the transition happen from time to time and all that is represented in the state diagram. Then we have a communication diagram which talks about the interaction between the objects, how the objects interact with that, how the objects communicate among themselves. That's shown in the communication diagram. So in all, for a simpler project design, what we can do is the first and foremost thing is to write the use case diagram. The whole story begins with writing with the use case diagram, and then we rewrite the class diagram, and then we can continue writing the sequence diagram, state diagram, and the activity diagram. And once these diagrams are over, then identify the various components involved in the system and then see how they are interconnected, software components and all, and see how they are interconnected. And finally look at the various things like hardwares and softwares and how they are interrelated, how the whole thing is deployed through the deployment diagram. Yes, of course, all these issues we had already studied in our software engineering course, where it was very commonly known as software development life cycle. So there is a life cycle for any software development, and there we had seen that the whole process begins with the client coming to the developers and telling what the requirements are. That means requirement collection, requirement analysis, then we design it and then we implement it and we test it, and if things are okay then we deploy it. If it is not okay, then this is put in a loop and make sure that everything is done perfectly. So the whole thing begins with the requirements and the requirement analysis. We do the requirement collection from the client and make the analysis of that, and that analysis you can keep on writing in text and in terms of essays, thousands of pages, but doesn't make any sense. It has to be put in a concrete form. That is where the use case diagrams come to our aid. So here use case diagram identify the system functionalities, what all functions our system has to perform. That is shown as a use cases, and who all are interacting with our system. That's the external sources of external systems, external users who all are interacting with our systems are called the actors. So the use case diagram is the first thing we have to write any when we are beginning to design any software. So then comes our conceptual design. There we write the class diagram which identifies the core data structures, their responsibilities and relationships among the data and the data structures, and all that is defined in the class diagram. And then we have to look at how our system is changing with time, dynamic behavior. So we have to write the sequence diagram which shows the object interactions for each of the use cases, and then activity diagram which shows the workflow, the flow chart for each of the use case. Then state diagram shows the life cycle of the objects that change their state from time to time. Once this whole thing is done, then we go for the architectural design. That's a component diagram. We write it where we define the software modules, components, and their interfaces. So that makes one level ahead of one level higher abstraction. We get it, and then finally we deploy our system. So the deployment diagram we write, which maps the components to the hardware and the environment nodes and all that. What all we have designed, which part of the hardware should implement which part of the use case, or all that has to be finally shown in the deployment diagram. Okay, let's start our journey with the use case diagram. So we just had a brief idea about what whole design process is all about. So let's start our journey with the use case diagram. So it's we can say that it is turning a textual requirements into a visual blueprint. So when the requirement collection team has interacted with the client, that the client has given all the requirements were collected, and the analysis is done, that whole thing is put in the form of text, but that's going to be always confusing. Therefore, to make sure that there is no ambiguity in that, has to be converted into a visual form. So that's a visual blueprint of the textual requirements, is what the use case diagram is. It shows how users, like other actors, interact with a system. So it's going to show how the users interact with the system, and it answers questions like what can the system do from the user's perspective. So what exactly the system is doing, in if you think from the user's perspective what the system is doing. So just all the list of requirements are put together, and for these requirements we start working on creating the use case diagram. So here the actors are the people or the external systems interacting with our system, and use cases are the functions or the services our system is going to provide. And the system boundary is a box that defines what is inside, that is our system, and what is outside. So whatever use cases we have written inside the boundary, that is only the use cases are written inside the boundary, that is what we are going to implement it. And there are some external things who are going to interact with our system, like the user, admin, maybe the database and all that. So these are out of our purview, so we are not going to implement them. That is interacting with our system, so they are called the actors. So the basic elements, the actor is drawn as a stick figure. Example maybe a customer, admin, bank system, and so on. The use cases is represented with an oval with a name written inside that, and that is the way functions, like a login, place order, and all that. And there are associations between the use case and the actor, so the lines connecting the actors to the use case. So any actor is influencing the use case, or the use case requires any information from the actor, then only there will be a connection. If the use case is doing everything without external support, then there won't be any actor connection to that. It will be just inside the use cases are just put inside our system boundary. Then we have a system boundary, a rectangle enclosing the use cases. That's what we say, that this is all the things which we have written in the system boundary is what we are going to implement, nothing more, the nothing less. Why use case diagrams are important? So it's useful in requirement gathering, so they'll help to clarify what the system must do. So when we are writing the use case diagram, it gives very clear picture what our system must do. So from the requirement gathering, we convert it to use case diagram. There we understand each use case related with some requirement. Then it's a best communication tool, so it becomes very easy for non-technical stakeholders to understand what we are trying to tell them. If we talk in terms of technical jargons, they never understand anything, but if you put that in simple figures, then even non-technical stakeholders can easily understand what information we are trying to convey. So that makes the communication very easy. And scope definition, so which shows that the boundaries, so we are going to implement what is inside the boundary. So we are going to define a very clear boundary, what we are going to do, what we are not going to do, very clearly we mention here. And that makes the future part of the design, implementation and everything quite simple and easy. Then it is a foundation for other diagrams. So all other diagrams depend solely on the use case diagram. Any other diagram like a sequence diagram, activity diagram, class diagram, or any diagram, it depends solely on the use case diagram, unless until you have converted the requirements into use case diagram, other things cannot start. Therefore that's a foundation for other diagrams. Then the question is, how do we decide the what are the actors, what are the use cases for writing the use case diagram? So the first step is to gather and understand the requirements. So take the software requirement specifications or the problem statement. So the requirements usually say things like the system shall allow customers to view products. So when we are talking about any system, when you are talking about any software requirements, usually the sentences look like this. If one requirement will be one sentence and it looks like this, and if we just look at the sentence carefully, then we find two important things. One is a noun and one may be a verb. A noun usually becomes an actor, and the verb will be the action taken, that is a function we are going to adopt, a function we are going to develop and all that. So that becomes a use case. In this case it says that system shall allow customers to view products. So the actor here is the customer, is an outsider one, and view product is a function we have to define. So whenever a customer wants to view product, we should have some functionality that can allow the customer to view the products. So view product becomes one use case, and customer will be an actor here. So another example will be system shall allow admins to update the inventory. Here admin is noun and it is an actor. Update inventory is an action taken, so functionality. So update inventory will be a use case. So what is essential is highlight who is involved and what actions they need. So two things we need to look at: who is involved and what actions they need. So who is involved is related with actor, and what actions they need is the use cases. The second step is now identify the actors. So from the requirements extract who interacts with the system. So like humans will interact with the systems, humans may be customers, employees, admins and so on. And there may be other external systems like payment gateways, databases, sensors, activators and all that. So all these which are out of our purview, we are not going to implement the databases, we are not going to generate the data, we are just going to use the data from the databases, or we are going to use the data from the what is generated by the sensors, or we are going to use the available payment gateway for making payments or receiving payments and all that. So all these are outside our system, we are not going to implement that, and that becomes an external system, and that is what actors are. Rule is an actor is an outsider, it doesn't belong to the system. That means we are not going to implement those things in our system, so they are out of our implementation. So outside the system boundary, but they need something from the system. Either they give input to the system or they take input from the output from the system or something. So that's actor. And the third step is to identify the use cases. Here from the requirements extract what functions the system provides. So what are the functions the system should provide? That's extract them. And so for extracting, just look for the verbs like login, search, update, generate, pay, approve and all that. And these verbs will be the use cases. So keep them at a functional level. So please make sure that keep these verbs in the functional level. not go down to the UI level, user interface levels, like clicking the button and all that low level, so that it become too many issues to look at. So make it at a higher abstract level, so that it becomes easier for us to put all the things at one place and look the whole thing at a time, so that it becomes easier for us to understand that. So an example, so without example we can't learn anything. So let's take an example. So requirement is the system shall allow customers to place an order. So here the use case is place order, and the customer is an actor. The requirement is the system shall notify the customers via email. So send notification is the task we have to do. The system has to perform some action like sending the notification, so we can call it a send notification, that call it one use case. The use case is the send notification. So one side the customer is involved in that, other side the email system is involved in that. So customer will be sent through the email. So email is an external world and customer is an external world. So email and customers are the actors here, and send notification will be the use case. So some more examples, if you look at it, the example statement, users can register and place orders. So here user is the noun, and who is making all the actions. So user will be the actor. Two verbs we have, register and place order. So register and place orders are the two use cases we have identified from this statement. Other statement can be admins manage users and view reports. So here manage users and view reports are the use cases, and admin is an actor here. Delivery agent accepts the assigned order. So accept order is the use case. The delivery agent will be. Then the step 4 is draw that system boundary and put all the use cases inside the boundary, and place all the actors outside the boundary. Connect the actors to the relevant use cases with straight lines, no arrows between this actor and use case connections. And then look for any relations are there among the use cases. If so, then put it. So it's an optional, not compulsory one. So if there are any relationships like dependencies are there, so one action depends on another action. So if there is such thing, then we can use the add the relationships. Like, so before transferring the money, the user must log in. Yes, without logging in, the transfer cannot take place. Therefore it is essential to log in before money transfer. So the money transfer should include the login. So there will be login to money transfer include relationship that says that if you are working on that use case money transfer, then make sure that that previous one, that is login, has done or not. If no, then this cannot be taken up. But there are some situations where it is optional, like receipt may be printed after payment. It's not essential that after every payment receipt should be printed. So sometime if it is preferred, then it will be printed. The use case make payment extends to another use case like print receipt. So that is optional. If user wants the receipt only, then it goes there. But in the previous one, whether user wants it or not, without login money transfer cannot happen. So this type of relationship, that's include and extend to relationship, we just try to identify and then put it on the use case diagram, so that it is very clearly understood that there is an include relation. That means the before anything happens, the earlier one must have happened, otherwise the other one should not be allowed. So that information should be properly put it on the paper. So that's what the relations between the use cases represent it. And finally the sixth step is about validating it. Check with the stakeholders. So just find out, go back to the stakeholders like your client, and sit with them and see that each requirement is mapping to a use case or not. So whatever they wanted, is it visible on the use case or not? Some use case should satisfy their requirements. Every requirement should be satisfied by at least one use case. So no requirement should be left out in our use case diagram. So we have to sit with the stakeholder and make sure that every requirement is visible in the use cases. If yes, continue. If no, then look for what is missing and add those things, add new use cases and make the things work. Then does every actor need appear? So do we, so many things come in, so do we just verify whether every actor is really required to be put it on there? So some as a discussion we keep talking about that, is it really required? So is it like when we say user, a user, it appears that the user is connected to every activity of the system, but no, user is not connected with every activity of the system. User may be connected with the login, user may be connected with some giving some inputs that are asking a query what the user wants and all that, and after that the whole system has to do it, and at the end the final results have to be transferred to the user. All the intermediate things user need not know. So no, so just make sure that all the actors put on the use case diagram are really required or not, and every actor, is it appearing on the use case diagram or not? Both way we have to look at it. Any functionalities are we missing? Yes, we have to verify that. If we are missing, make sure to add them. Okay, then let's take up an example, converting an example of e-commerce requirements to use case diagram. The requirement says that the customer shall be able to search products. So here customer is a actor and search product is a use case. A requirement says that customer shall make online payments through payment gateway. So here the actor is customer, payment gateway, and use case is make payment. So payment gateway is outside our boundary, therefore it is an actor, and use case is only make payment. Requirement is admin shall update the inventory. So here actor is an admin is the actor, and use case will be the manage inventory and so on. So to take up finally just take one full example and try to build a simple use case diagram. So for that let's take a online food delivery system. The requirements for this are customer registers to our app, then customer has to log in. So we need some way to update the profile by the customer, and we need functionality for the customer to order the food, and their admin can manage the user details and all that, and there is a chef who is preparing the order, and there is a delivery guy who delivers the food finally from the restaurant to the customer's address. So these are the various requirements, and if you put that requirements, then the first one says that customer is an actor, register is one use case. Second one says that customer is actor, login is a use case, customer is actor, update profile is use case, customer is actor, orders food is use case, admin is actor, manages user is use case, chef is actor, prepares order is use case, delivery guy is actor, delivers the food is the use case, and so on. If you just put that all in one place instead of talking this for hours together, just put this and the whole picture is clear and very clearly visible, that all the yellow, all the ovals are shown inside that rectangular box, and the top of the rectangular box it is written online food delivery system, and that whatever that box is, that is the system we are developing. Just for our convenience we have colored the use cases. So the register is one use case, that has to be done by the customer. Login is a use case, has to be done by the customer. Manage the profile is the use case, has to be done by the customer. Order the food is done by the customer. Manager user is an use case, is under the control of administrator. Manage the customer order is a use case under the control of chef. Manage delivery status and all that is a use case under the delivery guy actor. So that's how we convert all our discussions, hours or months of discussions onto one sheet. Everything is frozen onto one sheet, and that one sheet is what we call use case diagram, and that makes whole requirements visible and becomes very clear. No ambiguity, no confusion. Whoever sees this understands only one thing, and that is what the developer is trying to tell. So no more confusions, no more ambiguity, no language barrier, nothing. Everything is clear because that's the standard way of writing it. And another thing we missed is there are two types of actors. One is a primary actor who initiates the activities, and there are secondary actors who just take the order and respond back. The customer initiates the activities, so customer is primary actor. Admin is a primary actor, initiates the activity. The chef will start his preparation only when he gets an order. So chef will not initiate any activity. Therefore, a chef is not a primary actor; he is a secondary actor. The same way, delivery guy will start his activity only when the system tells the delivery guy to begin the delivery action, go to that restaurant, collect the food, and go to that customer and give the food to that, deliver the food to that person and all that. So this whole information is given to the delivery boy. So delivery boy starts his actions only when receiving the information from the system. So this chef and delivery guy are the secondary actors, and customer admin are the primary actors. As a standard, all the primary actors are put on the left side of the system, and all the secondary actors are put on the right side of the system, so that makes even the things more clearer. So that's about how to put all our ideas onto paper in a small sheet of paper. Every idea to be put on paper. For that we use case diagram, and this use case diagram is the starting point for all other activities we do in future while designing the software system. So that's it for the use case diagram. Thank you.